All right, Kellen and Aubrey, we are on 5-2. This is a homework assignment for 5-2, number 2 and 4 through 12. All it's like a front and back, so you get to throw the second page away again, right? Okay, so that's kind of nice. All right, let's rock and roll. We are talking about. Write this down. Congruent triangles. We got to talk about that word first. Okay, congruent. First of all, there is a symbol that we use for congruent because we're lazy in math, and that symbol is, do you know?
Triangle with a squiggly mark.
What?
An equal sign with a
An equal sign with a squiggly mark. I think it's called a tilde in Spanish, right? Is that thing called a tilde? Okay, so if you want to be lazy with me, congruent, you do the equal sign with the squiggly. I will use that symbol, so don't come at me and say, what does that mean? Okay, the equal sign with the squiggly means congruent. Now, what does congruent mean? The same what? Okay, both of those, same shape and same size. Both of those things have to take place in order for something to be congruent, right? Same shape, same size, exactly, right? There is another term in math, shush. There is another term in math that we use where it is the same shape, but different size. No. Same shape, different size. Nope.
Diatomic?
No.
No. What are we talking about?
If they're the same shape, same size, they're congruent. If they're the same shape, different size, they are under a dilation, right? But they are considered similar. Like similar triangles, you do like the proportions, like cross, multiply, divide for similar triangles, right? Okay, we'll get to that. But they are considered similar if they're same shape, different size. We're doing same shape, same size, so congruent. Got it? All they're going to do in order for these things to be congruent is they're going to like shift them, or they're going to rotate them, or they're going to whatever. If they stretch at all, or reduce in size, that's not going to be congruent. That's going to be similar instead. Okay, here we go. Congruent triangles. Go to example 1. Identify. This, you're going to hate this part. This is number 2 on your homework assignment, by the way. Example 1 corresponds to number 2 on your homework assignment. This is how you do number 2. Ready? Identify the corresponding parts. It says, show that the polygons are congruent by identifying all congruent corresponding parts. Identifying all the congruent corresponding parts. Then write a congruence statement. So here's what we have.
4 and 5.
What?
That's also 4 and 5 too, not just number 2.
Ugh. Okay. All right. But number 2 I know specifically is like that. All right. So the parts of these shapes, these are not just triangles. These are, it looks like trapezoids, right? They look like trapezoids. Okay. But they're quadrilaterals. They're 4-sided figures. Okay. And the parts of them are, we have angles and we have sides. Okay, those are all the parts. So here we go. This is kind of cumbersome. This is like the part that takes forever. Sorry. Angles. Let's start with angle A. And I want to say angle A is congruent to some other angle. How do I know which one angle A goes with? Angle W, because he has one little loop-de, right? Angle A goes with angle W. All right, let's then go to angle B. Angle B is congruent to angle X, because there's 2 loop-Ds. Angle C goes with angle Y, because there's 3 loop-Ds. And angle D goes with the only one that's left, angle Z, right? Because there's 4 loop-Ds. Got it? This is the pain in the butt. Like, for this problem, you have to actually list these out, all right? Then let's move on to sides, okay? How do I name the sides? Like, give me one side of one. Let's start with AB, right? Okay, if we start with AB.
Why don't we start with the one there?
I don't care. You don't, it doesn't matter. AB. If we go AB, which side corresponds to AB? I'm going to go WX, okay? And here's how you can cheat, by the way. AB goes with WX. I don't even have to look at the thing, right? Like AB goes with WX, like they're in that order, right? Okay. The next side, I don't even have to look at the thing, is BC. BC is going to go with XY. Do you see how that works? Yeah? Woo! BC, XY. Then I have CD goes with YZ. But there's another side. DA, or you can go AD, doesn't matter. We can go DA, that's fine. DA goes with ZW. Technically, it doesn't matter what order they go in, but I always like to put them in order because, like, it will matter later, okay? So, angles, sides. Then, the last thing, so that was the part. It says identify all the corresponding parts. Those are all my parts, my angles and my sides. And there's 4 in each, because this is a 4-sided figure. Then it says, then write a congruence statement. So write this down. Congruence statement. Here's what the congruence statement says. This guy is a quadrilateral, but it's also called a polygon. So I'm just going to call it a polygon. I have poly. What do you want to call the first poly?
Poly A.
A, B, C, D. We name it with all the letters. Polygon ABCD is congruent to polygon. This is where it matters. You have to go in the correct order. So if I list A first, which one goes with A? W. B next, what goes with B? X. C has to go with Y. D has to go with Z, right? If you can call this polygon DCBA, but if you do that, you have to call this polygon ZYXW, yeah? It doesn't matter what order you go in as long as they match each other. Got it? What? Just wait a second. Just, I know what you want. I know that enough Spanish, right? Good? So here are your corresponding parts. Here's your congruent statement, right? If this was a triangle instead of a polygon, I could either say TRI or I could write this symbol because that's triangle, right? Whatever. Okay? But congruent statement. What? What are you talking about? But we don't necessarily know that that's a trapezoid. We will learn in chapter 6, which is the chapter after this, when we study this. That's like my favorite chapter. Chapter 6 is my favorite. There's no proofs. Well, I don't think so. Kind of. There might be a few proofs. Not many. And we learn about shapes. So we learn about squares and rectangles and trapezoids and rhombuses and all the things, right? That's my favorite. Okay. So anyway, okay, go to the next. Example 2. Example 2, the middle of the next page. Now, this is important. Are you ready? When they say in this diagram, they give you this. This is called the congruence. Whoop. Congruence statement. Okay, don't overlook this thing because this guy tells you what pieces go with what pieces. So I know that angle R is the same as angle T. I know that angle S is the same as angle V. I know that V is the same as S. That's confusing. That's confusing.
Okay. So look at the triangle.
So if I'm looking at over here at RSV, they're saying this angle S is not the same as this angle S. This angle S is the same as this angle V, right? And this angle V is the same as this angle S. Do you see that? Okay, so that's why they put it in that order. Got it? Be careful. All right, we got to solve for some things. They say that this is 78 degrees. And this is 90 degrees. So let's like swap them. This is 78 degrees and this is 90 degrees, yeah? We want to solve for x, which is over here. How do you do that?
78.
All of these are 180, right? 78 plus 90
78.
is 168. And if I subtract from 180, that's a real small angle. That's like 12 degrees or something.
Yeah.
12 degrees. There you go. 12 degrees. Beautiful. Okay. All right, now. This is a little bit confusing because they're throwing angles and sides at you, okay? So notice that on the X, it has the degree symbol, right? Because you're solving for an angle, right? You see that? Over here, Y does not have a degree symbol on it. You're not solving for an angle. It would have an arrow there, right? You're solving for this side. Do you see that? Okay, sometimes the hardest part is figuring out what they're like actually pointing to, right? So what is 2y minus 1 equal to? 24. Do you see that? It's not equal to 24.5. It's equal to 24 because it's like swapped. Got it?
It's mirrored.
Yeah. So to solve for y, I want to go 2y minus 1 equals 24. And then I add the 1. Ugh. 2y equals 25. Gross. X or y is how much? 12 and a half. Okay? Happy with that? So, if there's any question like which side goes to which one, look back at your congruent statement and it will tell you exactly which side, right? Like if I'm looking at side RS, RS goes with TV, right? In that order. Got it? Confusing? All right, whatever. All right, last thing. This is something called the third angles theorem, and it is important to note. So go to that page. Third angles theorem. This is another shortcut. My shortcut people who want to go faster on the ACT. Here's your shortcut. Ready? And this kind of sounds like a stupid shortcut, but like in the moment, you forget about it, right? Okay, so here you go. Here's your shortcut. If angle C matches angle K, they're the same measure. How big does that look? 70 degrees, 70 degrees, 70 degrees, right? And angle B matches angle J. How do I know? Because there's two loopties. B looks like, I don't know, 60 degrees. They don't have to mark the third angle, but by default, don't those third angles have to be the same? Like, if I add these together, that's 130, this guy would have to be 50 degrees. If I add this together, that's 130, this guy would have to be 50 degrees. If they don't mark that the third angles are the same, and the other two are, they're the same, right? That makes sense? So, there you go. Got it? That's something called the third angles theorem. All right. Next. We're not going to go through the proof. Let's not go through the proof. I don't want to go through the proof. There you go. Okay, go. What?
We do 2 together.
2. Oh, you got to do 4 and 5 on your own. Okay, we'll do 2 together. That's fine. Okay, 2. 2 and 4 and 5 are all the same. Ugh. 4 is going to be awful. Why is 4 awful? Because it's a pentagon. There's 5 of them. Okay, show that the polygons are congruent by identifying all the corresponding parts. The parts are the angles and the sides, right? So let's make a column of angles. And let's make a column of sides. Okay, let's start with the angles first. Okay. Tackle one triangle first. So let's say this is my number 1 triangle. Give me an angle. J. Angle J goes with which angle on triangle 2? Angle L. All right, we did the easy one first. Okay, the next one. Angle what? K? Which one does angle K go with? M. Yeah? Do you see that? It's like rotated, right? So like this guy is like rotated around.
Basically.
Okay? And then the last angle of the first triangle is angle M, and angle M goes with angle K. Now, this is confusing. This angle K is not the same as that angle K, true?
True.
Right? This is a different angle K. This angle K is talking about this angle K. This angle K is talking about this angle K. Got it? Woo! Okay, next. All right, sides. Give me a side. KL. Okay, she's going with KL. All right, if we go KL, it's got to go. I'm going to go MJ just because K goes with M. So I'm going to go MJ. That doesn't particularly matter, but I want to go in the same order. Okay, so K, L, and MJ. Got it. I just broke it. It's fine. That thing falls apart all the time. All right, go ahead. What's next?
JK.
JK.
And
Ha.
L.
And LM. I'm going to go LM in that order. Okay. All right. Next. What? What's the third side? KM. KM goes with MK. Right? Right? Okay, got it? All right, that's not it. Then write a congruent statement. This is a triangle, so we'll call it triangle whatever is congruent to triangle whatever. All right, let's name the first one. Triangle 1. KJM. KJM in that order. So if we go KJM over here, we got to go what? MLK, right?
Martin Luther King.
Oh my gosh. So funny. So funny. Okay, there you go. Got it?
Kind of.
All right. Down here for number 4, when you write the congruent statement, those are not triangles, so you have to call them like poly whatever is congruent to poly whatever, right? And you name them with all the letters. Okay? 5, you can do triangle. Got it? Okay, so angles and sides, those are kind of a pain in the butt, but there you go. Good? Beautiful. All right. Goodbye, Kellen and Aubrey.